Hi everyone. In today's class, we are going to discuss how to measure voltage and current against individual resistances in an electrical circuit. Objective: at the end of this video, you will be able to measure the voltage and current in DC and AC circuits against resistance. First, let's discuss the DC circuit. We already discussed the relationship between voltage, current and resistance using Ohm's law. According to Ohm's law, it is given V is equal to I into R. I is equal to V upon R. R is equal to V upon I. Measurement of voltage and current. Voltage can be measured using a voltmeter and it should always be connected in parallel to the circuit. Current can be measured using an ammeter and it should be connected in series with the circuit. Measurement of voltage and current in series circuits. Step 1. Connect a 12-volt battery, a switch S and an ammeter ranging from 0 to 200 milliamps in series with a metal film resistor of 100 ohms. Connect a voltmeter ranging 0 to 15 volts in parallel to the circuit. Step 3. Close the switch S and energize the circuit. Note the current and voltage values from the ammeter and voltmeter readings respectively. Substitute the values in the formula R is equal to V upon I and ensure the calculated value is equal to 100 ohms. Now open the switch and add another 100 ohm resistor in series with the existing one. Close the switch S and note the ammeter and voltmeter readings. Substitute the values in the formula R is equal to V upon I and ensure the value you get is 200 ohms since the resistors are connected in series. Measurement of voltage and current in a parallel circuit. Connect two resistors each having 100 ohms in parallel with each other. Connect a 12-volt battery, a switch S and an ammeter ranging 0 to 500 milliamps in series to the parallel circuit. Make sure the switch S is in open position. Step 3. Connect a voltmeter long enough to measure the 12 volts parallel to the circuit. Close the switch S to energize the circuit. Note the current and voltage values from the ammeter and voltmeter readings respectively and substitute the values in the formula R is equal to V upon I. Ensure the calculated value is equal to 50 ohms since both resistors are connected in parallel. Open the switch S and connect another resistor R3 with 100 ohms in parallel to the existing R1 and R2 parallel connected circuits. Energize the circuit by closing the switch S. Note the readings of the ammeter and voltmeter and substitute them in the formula R is equal to V upon I and ensure the calculated resistance value is equal to 33.33 ohms since all the three 100 ohms resistors are connected in parallel to each other. Measurement of voltage and current in AC circuits. Measurements in AC circuit can be done only with the help of moving iron instruments, not with moving coil instruments. Moving iron meters can be identified by an AC or DC symbol or with a non-linear scale. Measurement of voltage and current in a series AC circuit. Connect a 40-watt lamp to a 240-volt AC supply, a switch S, and an ammeter ranging from 0 to 1 amp, all in series. Make sure the switch S is in open position. Connect the voltmeter ranging from 0 to 300 volts in parallel to the circuit. Close the switch S and note the ammeter and voltmeter readings respectively. Substitute the values of voltage and current in the formula R is equal to V upon I. Ensure the calculated resistance is equal to 1440 ohms. You can verify this using the formula P is equal to raised to the power of 2 upon R. R is equal to V raised to the power of 2 upon P. R is equal to 240 into 240 upon 40. R is equal to 1440 ohms. Open the switch S and now connect another 40-watt lamp series with the existing 40-watt lamp. Now close the switch S and note the readings of the ammeter and voltmeter and substitute in the formula R is equal to V upon I to ensure the calculated resistance value is equal to 720 ohms. You can verify this using the formula P is equal to V raised to the power of 2 upon R. Here, two lamps with the same wattage are connected in series and the applied 240 volt AC is distributed equally at 120 volts at each resistor. At lamp 1, P is equal to V raised to the power of 2 upon R. R is equal to V raised to the power of 2 upon P. R is equal to 120 into 120 upon 40. R is equal to 1 440 by 40, R is equal to 360 ohms. The same resistance occurs at lamp 2. So the total resistance of two lamps in series becomes 720 ohms, which is equal to the calculated ohms. Let us discuss how to measure the voltage and current in AC circuits with series and parallel combinations. Take three lamps, namely L1, L2 and L3. Let the power and operating voltage of each lamp be 100 watt, 240 volts. Connect the lamps L1 and L2 in parallel to each other. Connect the lamp L3 series to the circuits. Connect the 50 Hz AC supply, switch S, and moving iron ammeter ranging 0 to 500 milliamperes, all in series, to the circuit. Ensure the switch is in open position. Connect a moving iron voltmeter ranging 0 to 300 volts parallel to the circuit. Energize the circuit by closing the switch S. Note the voltmeter and ammeter readings in the tabulation. Calculate the resistance R by substituting the values of voltage and current in the formula R is equal to V by I. Now, let us verify the obtained value theoretically as follows. Let us find the resistance of lamp L1. P is equal to V raised to the power of 2 by R. So, R is equal to V raised to the power of 2 by P. Substitute the value 240 as V and 100 as P. R is equal to 240 into 240 by 100. R is equal to 576 ohms. The resistance of the lamps L2 and L3 also be 576 ohms, since all the lamps has same wattage and operating voltage. So the circuit can be drawn as in the image. Let us find the total resistance. R is equal to R1 into R2 by R1 plus R2. R is equal to 576 into 576 by 576 plus 576 equal to 288 ohms. Now the circuit looks two resistors in series with 288 and 576 ohms respectively. Just add the two resistance value since they are in series. So the total resistance is 864 ohms. R is equal to 864 ohms. Compare this value with measured value and ensure they are same. Thanks for watching. Have a good day.